Hello my gingers and chilies, welcome back to my channel Chemistry का बच्चन. Today we are going to study colligative properties. ठीक है? So already we had done the first part and now very important part we are going to do colligative properties जो आप पहली बार कर रहे हो. Now what are colligative properties? ध्यान से सुनो. Colligative properties are the properties which only depends upon the number of solute particles present in the solution. क्या बोला? It only depends upon number of solute particles present in the solution. It does not depend upon the nature. Nature of the solute it does not depend upon. मतलब जितने ज्यादा आपके पास सोल्यूट पार्टिकल्स होंगे उतने ज्यादा हाई आपकी कॉलिगेटिव प्रॉपर्टी होगी. सो डेफिनेशन इज वेरी इंपॉर्टेंट. कॉलिगेटिव प्रॉपर्टी इज द प्रॉपर्टी विच ओनली डिपेंड्स अपॉन द नंबर ऑफ सोल्यूट पार्टिकल्स विच आर प्रेजेंट इन द सॉल्यूशन बट नॉट अपॉन द नेचर ऑफ द सोल्यूट पार्टिकल्स. कॉलिगेटिव प्रॉपर्टीज 4 डिफरेंट टाइप्स की है, 4 पार्ट्स में डिवाइड होती है. वन इज कॉल्ड रिलेटिव लोअरिंग ऑफ वेपर प्रेशर, जो हम सबसे पहले पढ़ेंगे. एक बार पढ़ा चुका हूं, वापस आपको बता दो. सेकेंड इट इज कॉल्ड एलिवेशन इन बॉइलिंग पॉइंट. थर्ड इज कॉल्ड डिप्रेशन इन फ्रीजिंग पॉइंट. एंड चौथी कॉलिगेटिव प्रॉपर्टी को बोलते हैं ऑस्मोटिक प्रेशर. So, these are the 4 colligative properties which we are going to study one after another. So, let's start from RLVP, relative lowering of vapor pressure. The first colligative property is RLVP, relative lowering of vapor pressure. Last time Raoult's law के साथ आपको सिखाया था, वापस देख लेते. Relative lowering of vapor pressure expression is going to be in mathematical form यहाँ लिखा हुआ है, and how it is being stated. When a non-volatile solute means which cannot evaporate, which cannot easily fly. कौन कौन से 3 एग्जाम्पल दिए थे? यूरिया, ग्लूकोज, सुक्रोज, जो बार बार आएंगे. इज डिसॉल्व्ड इन अ सॉल्वेंट. पानी के अंदर अगर आपने उसको डिसॉल्व किया, द वेपर प्रेशर ऑफ द सॉल्यूशन इज गोइंग टू बी लेस देन द वेपर प्रेशर ऑफ द प्योर सॉल्वेंट. मतलब पानी अगर अकेला होएगा तो आराम से इवोपरेट करेगा, लेकिन उसके अंदर अगर आपने नॉन वोलेटाइल सॉल्यूट डाल दिया देन इट कैन नॉट इवोपरेट इजीली, एंड दैट इज नोन एज लोअरिंग ऑफ वेपर प्रेशर. सो लोअरिंग ऑफ वेपर प्रेशर अगर कोई बोलेगा तो वेपर प्रेशर ऑफ सॉल्वेंट माइनस वेपर प्रेशर ऑफ सॉल्यूशन. एंड व्हाट इज रिलेटिव लोअरिंग ऑफ वेपर प्रेशर? दिस इज कॉल्ड रिलेटिव लोअरिंग ऑफ वेपर प्रेशर. इट इज द रेशियो ऑफ lowering of vapor pressure to the vapor pressure of a pure solvent, and that is equal to the mole fraction of the solute, जो हम लोग Raoult's law में derive कर चुके हैं. अब इसको मैं और ज्यादा expand करूंगा तो P naught minus P upon P naught is equal to N2 by N1 plus N2. Now for a dilute solution N2 is very less than N1, because जितने भी आप यहाँ पे solutions पढ़ोगे वो कौन से होंगे? डाइल्यूट होंगे. सो N2 इज वेरी लेस कंपेयर टू द N1. तो ये हो जाएगा P naught minus P upon P naught is equal to N2 by N1. What is N2? W2 by M2. What is N1? W1 into M1. तो अगर आप ध्यान से देखोगे तो P naught minus P upon P naught, that is relative lowering of vapor pressure, is inversely proportional to the molar mass of the solute. That means it is a colligative property. It is a colligative property. What is P naught? Vapor pressure. जब भी नॉट आएगा pure solvent याद रखो. So it is pure. So P naught is a vapor pressure of a pure solvent minus vapor pressure of a solution divided by the vapor pressure of a pure solvent. And 2 का मतलब बताया हुआ है solute होता है. So this is mole fraction of a solute. So this is the first expression जिसके ऊपर हम लोग numericals करेंगे at the end of the lecture, and this is very important part with respect to theory as well as entrance. Now we are moving to the second and third colligative property. First, what we had done was relative lowering of vapor pressure, and today I am going to teach you elevation in boiling point and depression in freezing point. The first question comes to your mind, what is boiling point? So boiling point you don't have to remember from 10th class, वाला definition नहीं चलेगा. Boiling point is defined as the temperature at which the vapor pressure of a liquid is in equilibrium with the vapor pressure of a gas. मतलब liquid has to be in equilibrium with a gas, मतलब liquid is converted into a gas 10th class, but यहाँ पे the vapor pressure of a liquid is in equilibrium with the vapor pressure of a gas. That is known as boiling point. Now what is elevation in boiling point? पानी लिया और boil किया, कौन से temperature पे boil होएगा? 100 degree Celsius पे, right? So it is going to boil at 100 degree Celsius. Now if you are going to see the salt plus water or sugar plus water, add sugar and boil the water, you are going to find that the boiling point of this solution is going to be higher than 100 degree Celsius. और इसी डिफरेंस को बोलते हैं एलिवेशन इन बॉइलिंग पॉइंट. मतलब जब आपने सॉल्वेंट लिया तो बॉइलिंग पॉइंट आया पानी का 100 डिग्री सेल्सियस, और जब आपने पानी के अंदर नॉन वोलेटाइल सोल्यूट डाला, राइट, दैट मीन्स द बॉइलिंग पॉइंट ऑफ अ सॉल्यूशन कंटेनिंग अ नॉन वोलेटाइल सोल्यूट इज ऑलवेज हायर देन द बॉइलिंग पॉइंट ऑफ अ प्योर सॉल्वेंट, एंड दिस डिफरेंस इन बॉइलिंग पॉइंट इज कॉल्ड एलिवेशन इन बॉइलिंग पॉइंट. So I hope the definition or the statement is being clear to everyone. Now how the elevation in boiling point is being denoted? It is denoted by delta TB. Delta TB मैंने बताया हुआ है, not मतलब क्या होता है? Pure solvent. So boiling point of a solution minus boiling point of a pure solvent is called elevation in boiling point. तो definition आप mathematically भी समझ सकते हो. And experimentally it is proved that delta TB is directly proportional to the molality of the solution. What is molality? Number of moles of a solute per kilogram of the solvent. And proportionality, when removed, then you are going to get abuloscopic constant. What is Kb called as? Abuloscopic constant. Tough name, but you have to remember. So Kb stands for abuloscopic constant. Theory में याद नहीं रहता है तो बोल सकते हो elevation in boiling point constant. But entrance के लिए याद रखो abuloscopic constant. And how will you define abuloscopic constant? Abuloscopic constant is defined as the elevation in boiling point when the molality of the solution is unity. When the molality of the solution is unity. और किसी ने Kb की यूनिट पूछी तो व्हाट इज द यूनिट ऑफ डेल्टा Tb? केल्विन. और इसकी क्या होती है? मोल्स पर केजी. तो Kb की यूनिट क्या हो गई? यूनिट हो गई आपकी केल्विन केजी पर मोल. वेरी वेरी इंपॉर्टेंट. सो Kb की आपको यूनिट भी मालूम पड़ेगी. और Kb यू ऑल्सो हैव टू नो the another formula for entrance, that is RT naught square. What is R? Universal gas constant. What is T naught? The temperature of the pure solvent divided by 1000 multiply by, क्योंकि boiling point है तो latent heat of vaporization. What LV stands for? Latent heat of vaporization. कभी कभी आपको LV direct नहीं दिया जाता है, so that is enthalpy of vaporization, that is conversion from liquid to vapor state is called enthalpy change of vaporization divided by molecular mass of the solvent. That is same solvent only. So ये formula आपको याद रखना है, and that is what we call it mainly the expression. अब इसको अगर मैं थोड़ा और आगे बढ़ाता हूं तो डेल्टा TB is equal to Kb multiply by W2 upon M2 multiply by M1 in Kg. That is the formula of molality. And as delta TB is inversely proportional to the molar mass, we can consider it also as a colligative property. तो ये आपका हो गया elevation in boiling point. अब इसका ग्राफ भी देख लेते हैं. For theory purpose as well as entrance में बहुत कम पूछते हैं, but you should know it. Now it is a graph between the vapor pressure and the temperature. What is the definition of boiling point? The temperature at which the vapor pressure of a liquid is in equilibrium with the vapor pressure of a gas is called the boiling point. तो ये आपका AB जो curve है, that is the vapor pressure of a pure solvent. ऊपर क्यों है? Because everyone knows that vapor pressure of a pure solvent is greater than the vapor pressure of a solution. What is solution? Non-volatile solute, sugar बोला is added into it. तो उसका नीचे curve जाएगा, right? At certain point, so we are considering at this pressure the vapor pressure of a liquid is in equilibrium with the vapor pressure of a gas. तो इसका यहाँ पे है और इसका यहाँ पे. अब temperature देखते हैं. When you are observing the temperature, what you are finding? The temperature of this is going to be called TB naught, मतलब कम temperature आएगा और इसका temperature ज़्यादा आएगा और difference किया, then it is known as elevation in boiling point, that is delta TB. So I hope this part is clear to everyone. क्योंकि ये part आ जाएगा तो depression in freezing point is very simple. Exactly उसका copy है, थोड़े से changes करने. Now what do you mean by freezing point? The temperature at which the vapor pressure of a liquid is in equilibrium with the vapor pressure of a solid, then it is called freezing point. यहाँ पे क्या था? The temperature at which vapor pressure of a liquid is in equilibrium with the vapor pressure of a gas या liquid and solid है, तो बहुत easy है. अब आपने आइस लिया. What is the temperature of ice? 0 डिग्री सेल्सियस. अब उसमें कोई नॉन वोलेटाइल सॉल्यूट डाल दिया आपने. इज इट क्लियर? नॉन वोलेटाइल सॉल्यूट डाल दिया, जैसे कि मैं एग्जांपल लेता हूं, मैंने नमक डाल दिया एग्जांपल. इफ आई एम गोइंग टू ऐड सॉल्ट इनटू इट, द टेम्परेचर इज गोइंग टू ड्रॉप डाउन टू -23 डिग्री सेल्सियस. तो प्योर आइस का क्या था? 0 डिग्री. सॉल्यूट डाल दिया तो क्या हो गया? -23 डिग्री सेल्सियस. डिफरेंस कितने का है? 0 -23 डिग्री सेल्सियस, and that is only called depression in freezing point. That is called depression in freezing point. Another example you can think of anti-freezing agent called ethylene glycol, जिसको हम लोग ऐड कर देते in your along with your petrol. The reason? It depresses the freezing point, and in cold countries, right, you are going to find that your solvent is not going to be frozen down at a very low temperature. So, depression in freezing point का एक experiment भी देखते हैं. ये आप घर पे भी कर सकते हो, but take care, ज़्यादा लंबा मत खींचना. So this I have taken salt, and this is ice. Ice you can keep it in your hand for up to the time it melts. लेकिन अगर नमक रखा और नमक के ऊपर आप आइस रख के देखो, 1 2 3 4 5 6 7 8 9 10 11 12, oh, it's burning. That means the temperature along with the salt is being gone down, right? And as it is gone down, I can feel the pain, right? Experiment, do it, but don't prolong it. यहाँ पे वापस आपको हीरो बनने की जरूरत नहीं है, right? You don't have to show the guts. Just feel that is the temperature dropping, and that is what I mean to show you. ये experiment उसी के लिए, आपको दिखाने के लिए कि that the temperature drops down, and that is what we use it in ice creams. Is that clear to everyone? So this is called depression in freezing point. So mathematically कैसे बोलेंगे? Delta TF is equal to what? Delta TF is equal to freezing point of a pure solvent. Not लिखा है ना? Minus the freezing point of the solution. Example दिया 0 minus -23. So you will get 23 degrees Celsius, and that is called depression in freezing point. Delta TF is also, अब मैंने बोला था ये आता है तो ये free है. Delta TF is directly proportional to molality. Same. But this time delta TF is equal to KFM. What is KFM? KF is over here cryoscopic constant. वहां पे था ebuloscopic constant, यहाँ पे cryoscopic constant. Is it clear to everyone? So when we are talking about the KB ebuloscopic, KF cryo chemistry में bio में cryosurgery means at lower temperature. हर वक्त याद रखो, cryo means low temperature, right? So when we are talking about the cryoscopic constant, it is Kf. Definition पूछा तो cryoscopic constant is defined as the depression in freezing point. Depression in freezing point when the molality of the solution is unity. Same. Unit, same. Kelvin kilogram per moles. Is that clear to everyone? Formula same. खाली Kf आ गया यहाँ पे RT naught square. R is universal gas constant. T naught is pure solvent, right? Divided by 1000. इस बार solid में fusion है. That means what is fusion? Solid is converted into liquid. बराबर है, तो इसलिए LF लिखा है. वहां पे latent heat of vaporization था, boiling था इसलिए. और latent heat of fusion का formula भी same है. वहां पे था heat of vaporization, यहाँ पे heat of fusion. याद रखना, what is fusion? Solid is converted into liquid divided by the molar mass of the solvent, right? Now let's go to the graph of it. And जब भी आप ये दोनों कर रहे हो, दोनों को parallel learn करना. Once you learn parallel, you're going to find it out that it is very easy concept. And please remember, boiling point and freezing point are not colligative properties. Who are colligative properties? Elevation in boiling point and depression in freezing point. Is it clear to everyone? Vapor pressure is not a colligative property. Relative lowering of vapor pressure is a colligative property. So I hope the concept is clear to everyone. Now let's go to the graph of depression in freezing point. Let's go to the last part of today's lecture, and that is the graph of depression in freezing point. Now depression in freezing point, everyone understood the difference between the freezing point of a pure solvent and the freezing point of a solution, right? That difference is known as the depression in freezing point. अगर आप ग्राफ देखोगे तो सेम है जो हम लोगों ने बॉइलिंग पॉइंट में ड्रॉ किया था. द ग्राफ बिटवीन वेपर प्रेशर एंड टेम्परेचर. नाउ एवरीवन हैज टू नो द फ्रीजिंग पॉइंट का डेफिनेशन. फ्रीजिंग पॉइंट वापस डिफाइन करते हैं. फ्रीजिंग पॉइंट इज डिफाइंड एज द टेम्परेचर एट विच द वेपर प्रेशर ऑफ अ लिक्विड इज इन इक्विलिब्रियम विद द वेपर प्रेशर ऑफ इट्स सॉलिड स्टेट. ठीक है, तो एवरीवन नोज whose temperature is going to be higher, pure solvent or the solution? So of course it is going to be the pure solvent. ठीक है, इसलिए देखिए, first of all we all have to know that I have taken three different pressures. P naught is the vapor pressure of a pure solvent. इस बार मैंने दो solution लिए जानबूझ के, एक ही ले सकते थे, but दो for you, for explaining it to you. One is vapor pressure of solution 1 and another is the vapor pressure of solution 2 over here. Okay, so that's why it is written solution 1 and solution 2. What is solution 2? More concentrated. मतलब उसमें नॉन वोलेटाइल सोल्यूट और डाला हुआ है. एक में अगर आपने 1 ग्राम डाला है, दूसरे में आपने 5 ग्राम डाला हुआ है, एग्जाम्पल. And that is of course of a pure solvent. Is it clear? Now when you are going to see the graph, you are going to find from point C, right? It is going to point A, and at this point what is happening? At this point you are going to find that at point A there is going to be an equilibrium of vapor pressure of liquid as well as the vapor pressure of a frozen solvent, and the two of them are exist in equilibrium. So the temperature at which this is happening is known as TF naught. So at point A, what temperature is being denoted? TF naught. And what is TF naught? The temperature of the pure solvent. If you see the other two solutions, one is less concentrated, another is more concentrated. Of course, the freezing point of the solution is always lesser than the freezing point of the pure solvent. बराबर है, तो vapor pressure भी कम हो जाएगा. Yes, vapor pressure भी कम हो जाएगा. And as the vapor pressure is going to be decreased, over here the temperature is also going to be lesser. And the difference between two of them, जरूरी नहीं आप तीन बनाए, दो भी बना के दिखा सकते हो. So the difference between two of them is known as the delta TF. What is delta TF? Depression in freezing point. So I hope all the three colligative properties are now being clear to you. The fourth one we are going to do is osmotic pressure in my next lecture. So एक बार तीनों के तीनों रिवाइज कर लेते हैं. पहला है RLVP, relative lowering of vapor pressure, where the vapor pressure of a pure solvent is greater than the vapor pressure of a solution. Second है elevation in boiling point, where boiling point of a solution is greater than the boiling point of the solvent. सोचोगे तो बहुत easy है, रट्टा नहीं मारना है. और freezing point का मैंने experiment दिखा दिया. तो freezing point of a pure solvent is always greater than the freezing point of a solution. और elevation in boiling point and depression in freezing point दोनों को parallel करना है. Main formulas learn करने, delta TB is equal to KBM, molality का formula आता है, उसको expand करना, and of course you can crack all the numericals. कभी कभी KB डायरेक्ट फॉर्म में नहीं दिया होता है तो KB का फॉर्मूला भी याद रखना, दैट इज इक्वल टू RT नॉट स्क्वायर डिवाइडेड बाय 1000 मल्टीप्लाई बाय लेटेंट हीट ऑफ वेपराइजेशन. एंड सेम वे अगर आपको एलिवेशन इन बॉइलिंग पॉइंट याद है तो डिप्रेशन इन फ्रीजिंग पॉइंट में पहले उल्टा कर दो डेफिनेशन एंड उसके बाद फॉर्मूला इज ऑलमोस्ट एवरीथिंग इज सेम ऑन द एक्सप्रेशन साइड. खाली डेल्टा TB के बदले डेल्टा TF, KB के बदले KF, मोलालिटी सेम, बाकी सब फॉर्मूले में लेटेंट हीट ऑफ वेपराइजेशन के बदले फ्यूजन, अदरवाइज एवरीथिंग इज गोइंग टू बी सेम. सो बॉयज एंड गर्ल्स, आई होप द कंसेप्ट इज बीइंग क्लियर टू एवरीवन. सो लेट्स मीट in our next lecture. Take care and be healthy.